So now we are going to see the switching characteristics of IGBT. So this is also same. All the switching characteristics will looks like same, but the terms, that is, what are the terms related to turn on process and turn off process will be different. So here the IGBT is a voltage controlled device. The input voltage, that is control parameter, is VGE, that is the gate to emitter voltage. When the voltage is applied, the turn on process is initiated, and when the voltage is removed, the turn off process of the IGBT will be started. So here first one, at the point of the initiation, that is during the turn off condition, the voltage across the IGBT will be VCE, that is the maximum voltage, and the current flowing through IGBT is IC, that is the leakage current. And when the gate voltage is applied, it will take some time to turn on, that is turn on T on is equal to TDN, turn on delay time, plus TR rise time. So during the turn on delay time, the gate voltage will be increased from, has to be increased from the minimum voltage to the threshold voltage, and during that condition the voltage across the collector to emitter will decrease from the maximum value to the 90 percentage, that is maximum 100 percentage to decreases to 90 percentage of VCE, that is 0.9 VCE, and the current will increases from the leakage current value to the 10 percentage of the full value of collector current, that is IC is the rated collector current, and the time required for the current from to increase from the leakage current to the 10 percentage of IC is the delay turn on delay time. And during the rise time TR, we will have the perfect transitions, that is the voltage will drops from the 90 percentage of VCE to the 10 percentage of VCE, and current will rise from the 10 percentage of IC to 90 percentage of 100 percentage of IC. So that is the rise time, that is the time required for the rise of collector current. Both the additions of TDN and TR will be the total turn on time, and after that we will have the maximum value of current IC, and during the turn on condition the voltage drop across the device is VCES. And after that, at the instant of removing the gate voltage, we are having the turn off process, and during the turn off process also we will have three different time intervals, that is TDF, that is for turn off delay time, and for turn off delay time, and TF1, that is fall time 1, and TF2 fall time 2. And during the delay of turn off delay time, we are having you can see that the gate voltage is reduced from the maximum value to the threshold voltage at the instant, and the current is decreased from the maximum value of IC to 90 percentage of IC, and the current voltage remains same during the delay time. So that is gate voltage is reduced from maximum to threshold voltage, and TF1 is the fall time 1, that is during the fall time 1 the gate voltage is further decreased, and the current will decrease from the 90 percentage of IC to 20 percentage of IC, and the voltage will increase from the VCS minimum voltage drop to the maximum of 0.1 VCE. And during the TF2, that is fall time 2, the current will further reduce from 20 percentage of IC to 10 percentage of IC, and the voltage will rise from 10 percentage of VCE to maximum voltage of VCE. So T off is equal to TDF plus TF1 plus TF2. So this is explained over here. Turn on time is equal to TDN plus TR. TDN is the turn on delay time, TR is the rise time, and T of turn off time is the T off is equal to TDF, delay for off delay time of off period, and TF1 fall time 1 and fall time 2, initial fall time and final fall time. So next is the this is the switching characteristics of SCR. So the SCR will have some uh, three different regions for the turn on process, and also there will take some time for the turn off process. So SCR is a semi-controlled device. So semi-controlled device in the sense, if you are applying the gate signal, the SCR will be turned on. But when once the SCR is turned on, the gate will loses its control, and when the gate pulse is removed, the SCR cannot turn off. So for turn off process, we have to provide some computation circuit, or we have to reduce the anode current below the holding current, so that the SCR will get turned off. So it is a semi-controlled device. So turn on can be the controlling parameter. The control parameter is gate current. Since it's a current control device, if you are applying the gate current, the SCR will be turned on, and the turn off process is not controlled by the gate current. We have to provide some computation or the turn off circuit for the turning off of the SCR. So first one, we are having the gate voltage by applying the gate pulse. We are the turn on process is initiated, and it is started at the time of starting of the TD. So TD is nothing but the delay time. That is, the gate current rises from 90% of full value of gate current to the IG, maximum value of gate current IG, and during that condition, the voltage will drops from the maximum value of anode voltage to 90% of anode voltage, and the current will increases from forward leakage current to 10% of anode current. And in other words, we can say that the SCR is a 4-layer device, 4-layer 3 junction device. So PN is the 4 layers, and application of the gate current, it will inject some charges to the third layer. PN means the third layer will be the P-type layer. So on injection, on giving the gate current, that will inject some charges into the gate layer, that is P-type layer, and initially and after that the initiation of the anode current will be happening. So the anode current will be increasing. So the anode current will be at the minimum area during the after the application of gate pulse. When the gate pulse is removed, so when the gate pulse is removed, the SCR will loses its control to turn off the SCR. So first one, we can have the delay time. So during that condition, in the minimum amount of area of cathode, the current will flow, and after that rise time. The rise time is the current will increases from 10% of IA to 90% of IA, and the voltage decreases from 90% of VA to 10% of VA, and that is the time required for increasing the area of conduction from the minimum point surface area. That is, so here we can see first one, the gate current density is very less during the time TD, that is minimum area the current will flow, and after rise time TR, it will spread its area for the current distribution. And the third one, after TP, that is the spread time, the current distribution will be along whole area of the cathode. So the last one is the TP is the spread time. So during that, the current will increases from 90% to the maximum value of IA, and voltage decreases from 10% of VA to the on-state voltage drop of SCR. That is during the rise time, both the parameters will be at high value, that is anode current and anode voltage VA. So there will be some power loss across the device. So that is indicated in the fourth graph. And after that turn on process, we will have the steady state operation, and after that we are initiating the turn off process by means of computation, and it is initiated at instant T1, and during the time period T1 to T3, it is a reverse recovery time. So during the turn on process, some charges are injected to the layer, that is a gate layer, and during the turn off process, the injected charges will be removed. This already said the SCR is a four-layer device, that is PNPN. The trapped charges inside the layers has to be uh, draw out from the device for the turning off of the device. So the outer layers, the outer two layers, the charges are removed by means of applying a reverse current, so that the outer layer charges are easily gets removed during the reverse recovery time TRR. That is outer PN layers. Among the four layers, both the outer layers charges are removed by means of applying the reverse current. So the anode current will flow in a reverse direction, since the current or the charges are removed from the device. So the current will be in the negative direction, that is the recovery time TRR. And after that, a recombination, that is the inside two layers are will have some trapped charges, so that charges will take some time for the depleting, that is for the recombination to. We cannot remove the charges from the outer by means of any outer circuit, so it will the trapped charges will delete itself by means of recombination, so that will take some time. That is called the um, TGR. So the turn off time will be TQ is equal to turn off time, so that is device turn off time will be equal to reverse recovery time plus gate recovery time TGR. And after the instant of T4, there will be some time delay for the reverse voltage to reduce to 0, so that is the circuit turn off time. So always the circuit turn off time will be greater than the device turn off time. So the device turn off time TQ is equal to TRR plus TGR, and TC is equal to TQ plus some time required for the fully turn off of the device. So this is explained over here. T-on is equal to delay time plus rise time plus spread time. During delay time, the gate current reaches to 0.9 Ig, that is 90% of Ig, and the anode current rises to 10% of Ia, and VA, anode voltage, falls to 90% of VA, and the TD can be decreased by, the delay time can be decreased by applying high value of gate current and more forward anode to cathode voltage, so it will be in microseconds. And the rise time, it is a rise of anode current from 10% to 90%, and VA, that is falls from 90 to 10%. Spread time, that is current rise from 0.90 to the full value of 100% of IA, and VA falls from 10% to on state voltage drop. So the T on depends upon the gate signal wave shape, and it is minimum 4 microseconds. Switching characteristics of SCR, that is a turn off process, it is a TRR plus TGR. TQ is equal to TRR plus TGR, and TRR is a reverse recovery time to reverse current flow, sweeping out of holes from the top P-type layer and the electrons from the bottom N-type layer. Among the four layers, the top layer and the bottom layers, the charges are removed during this TRR, that is T1 to T2, T2 to T3. 60% of stored charges are removed from the outer layer, and the carrier density across J1, J3 begins to decrease. And during TGR, the gate recovery time, recombination of charges between T3 and T4 and independent of the external parameters, and TQ will be equal to 3 to 100 microseconds. In the TC, the circuit turn off time will be greater than the device turn off time TQ. Thank you.